ABCD is a trapezium in which AB is parallel to DC and its diagonally intersect each other at point O. Right? Show that this is a ratio. So we have a trapezium. So what is a trapezium? Right? To answer such questions or to know what is a trapezium in detail, please watch the basics. Okay? If not, you'll miss out a lot of property and stuff and you won't understand things. Right? So learn all the properties of a triangle, a quadrilateral and stuff, different triangles and in the basics and come back to this topic. Okay? So now I'll just tell what's a trapezium though, not the entirety. In entirety, we won't be able to discuss. So trapezium is a quadrilateral where we have one of the sides to be parallel to the other side. See, there are four sides, is it not? So just one pair of, one pair of sides are parallel. That's all, nothing else. This pair is not parallel or equal, and this pair is not equal and stuff. This is the minimum condition for a trapezium. Of course, it can be equal and stuff, things like that, but anyways. So this is the basic idea of trapezium. So the question is that if, and we have to talk about diagonal. Diagonal is lines connecting the non-adjacent vertex. So we have this to be O. Okay. We have to show that AO by OBO is equal to CO by OD. See, whenever you get such weird question, rearrange them. Because they're not even making sense. AO by OB, it's in this triangle and OC by OD. But as for BPT, it has to be in the same triangle. Is it not? In the same triangle, is the same length as well. So there is a way of proving it without using BPT. But, well, we are using BPT. So I would like to talk about being in the same triangle itself. Right? Same side. Okay, one, same triangle, same side. So we are not having that condition. So let's rearrange it. Rearrange it so that we still have the ratios, but at least it's in the same side. AO by OC is equal to PO by OD. Yeah, now it is in the same side, right? This side and this side. But BPT asks for a line which is parallel to the third side, right? So what we can do is we can take this point, draw a line which is parallel to the third side. So say in this case triangle ADC, if I call this as point NO, if I draw a line NO parallel to DC, I have that BPT now. So we have AO by OC, right, being equal to AN by ND, so BPT, and in the other triangle BO by OD will be equal to AN by ND. I'll explain in detail. So I hope you understood what we did over here. Because that ratio did not make sense as per BPT, we rearrange it. Again, there's another way of proving it. I'm sure most of you would be like, sir, we can prove it this way also. But as per, with the help of BPT, we can't prove it this way. Matlab, it's not easy to see. Of course, end of it, we are proving that only, but it's not easy to see. Right? So I'm teaching you tricks how to handle in your exam when you get weird ratios. Okay? So now we need to talk about the construction which we did. So we are looking at draw NO parallel to DC, where N is a point on AD. This implies NO is also parallel to AB, as AB is parallel to DC. Make sense? And then we'll move on to talking about what is given. AB is parallel to DC. Then AC and DB meet at O. Right? Small things, nothing much. So we're looking at to prove AO by OB is equal to OC by OD. So, of course, you can't write this in your answer script. What you can do is you can, in your question paper, you can't do this. So you can rearrange over here so that you understand what you have to reach. So if you reach this answer, obtaining this is not an easy, difficult task. So this is the trick that we'll use, right? Put a small scratch so that there's no confusion for the people who are correcting. It's only for your reference. Now we're looking at the proof. So we begin with, now you can pause and have a look. We want AO by OC. So which triangle should we consider? Remember that triangle should also have the parallel sides, right? It's quite simple. We have to consider triangle ADC. Okay. So in triangle ADC, as NO is parallel to DC, as per BPT, AN by ND is equal to AO by OC. Right? Very simple. AN by ND is equal to AO by OC. Now look at the next ratio which we want. So we're looking at which is that BO and OD. So which triangle are we talking about? In triangle ADB, as NO is parallel to AB, as per BPT, what is the ratio which you're looking at? We're looking at AN and ND and DO by OB, is it not? But yeah, if you are confused, just turn your book. You'll see that DN by NA, DN by NA is equal to DO by OB. But we want AN by ND. This is DN by NA. So what should you do? You flip both the sides, inverting both the sides. I hope you guys got the trick. In this chapter, whatever particular diagram you're looking at, tilt it so that you see it as a normal diagram with a proper base and stuff. If you're, if you are confused, if not, then you're set. So inverting both sides, right? We're looking at NA by DN is equal to DO by OB, right? So this we'll call it as equation 2. This will be your equation 1. So we are looking at this and this to be your negotiators. So clearly AO by OC is equal to DO by OB. So we are almost done with our answer. So from 1 and 2, we have DO by OB is equal to, what is the other ratio? AO by OC. AO by OC. All you have to do is cross multiply. So we have DO by OA is equal to OB by OC, hence proved. Right? So we saw the trick here is whenever you get weird expressions, weird ratios and stuff, rearrange them so that it makes sense to you guys, and draw lines wherever you need things to be parallel so that you can apply BPT. And just apply BPT and normal things. Check for the same side. That will be your negotiator, and link the other two sides, and you're done. Now you can pause and have a look.